In example 1, we're recognizing polynomial functions. Which of the graphs in figure 2 represent a polynomial function? Okay, now they can represent a function, but we want to find out whether it represents a polynomial function. And remember that a polynomial function means that it is continuous. So let's take a look at the first one. If I take my pencil and let's say I trace this entire graph, okay, I do not have any corners, well then this represents a continuous function, which means that the first one, which is going to be f, represents a continuous function, which is a polynomial function. Another one we can look at here is h. If we start tracing from here, okay, these are smooth curves and your pencil never removes, so therefore this is a continuous function, which means it's a polynomial function. Now if we take a look at this one over here, which is g, okay, we can trace here, but then it has a corner. So if it has a corner, it's not considered a polynomial function. Now it's a function, but it's not a polynomial function. And then the last one here, k, okay, if I start in that direction, then there's a break, and then I start from here, okay, this does not represent a continuous function, which means it's not a polynomial function. So again, the graphs of f and h are graphs of polynomial functions because they are smooth and continuous. Okay, and now the graphs of g and k are graphs of functions that are not polynomials. Okay, and the graph of function g, which is the absolute value function, has a sharp corner, and the graph function of k is not continuous. Now, question and answer. Do all polynomial functions have as their domain all real numbers? The question is yes. Any real number is a valid input for a polynomial function.